MVT for integrals, two different variations of what it looks like. F of c equals 1 over b minus a. Wait a minute. Isn't this average value? So this is saying that there's a value of f at c that equals the average value of f. That sounds a little bit like MVT, an instantaneous equals an average. We were talking about instantaneous rate and average rate. What if we just replace the word rate with f, calling the rate f? Instantaneous f versus average value of f? Or down here, it's a little bit different, because down here you actually have a height times a base. Isn't this just a rectangle? There exists a perfect rectangle that will be the exact same as the actual area under the curve. That's interesting also. So if you guys think about it, with left and right and midpoint and all that jazz, if we were to do the lowest bound, like a lower bound sum, we could choose like the lowest height of the curve and make a rectangle. Then we could choose the highest height of the rectangle, or for the rectangle. I could show you a quick example up here really fast. If we were to have some sort of curvy something. And we were to talk about the area under the curve in between here and here, for instance. That's the actual area. That would be the definite integral from a to b of f of x dx. Right? But I could do a lower sum. In my lower sum, I could use, for instance, the lowest height. And I could do one rectangle and say, all right, that's the lowest rectangle. That's the lowest the area could be. And then I could do an upper height, and I could say, all right, here's the highest the area could be. Actual area going to be somewhere between the red rectangle and the green rectangle. What do you guys think? Yeah. So what this theorem is saying, the second variation of it, there exists a perfect rectangle, is there is going to be somewhere, somehow, for some value of c, I'm making one up, I might be right, I might be horribly wrong, but some place where the actual, because I have an upper and a lower sum, IVT tells me, well, the actual is going to have to be somewhere in between. There exists some sort of perfect rectangle that would be the exact same as the actual itself. Anyway, but the other way of looking at this puppy is to say, wait a minute, isn't this just antiderivative of b minus antiderivative of a? All over b minus a equals, isn't this guy antiderivative prime? It's really just a variation of MVT. So when I gave you guys this example and said, hey, try it out, I was hoping that some of you had figured it out in homework last night, but long story short, we have two different formulas. Which one did you guys end up plugging into, the top one or the bottom one? Okay. Wait, bottom? You did bottom? Raise a hand. Who did top? Okay, who did bottom? Oh, okay. Either way should work, so let me go ahead and do the top just because more people raised the hand for that. But yeah, either one technically should work. I'm going to go ahead and do f of c is equal to 1 over b minus a times the definite integral from a to b of f of x dx. Now I'm going to go ahead and make it particular for my f. My f is, ooh, did you guys figure out I need a square root over there? If it says f of c, I have to plug a c into f, just like that. You guys agree? Oh, well, that's not too bad then. All we have to do is integrate, but we can't integrate until we anti-derive. Good. So wouldn't you guys think about x to the 1/2? You guys get x to the 3/2 all times 2/3? 0 to 3 times 1/3 equals the square root of c. Who are we supposed to be finding? Where is he? Underneath a square root, so don't we have to do some math? But before I can even undo, I know, I'm struggling today. Before I can get to the c and squaring both sides, I think I need to find this number. Did you love yourself? What am I talking about? Yeah. Did you rewrite this to be, well, you actually have some options. You could go ahead and make this 2/9 if you want. And then you could rewrite this to be, wouldn't that be x times the square root of x? Do you guys agree? X to the 1/2? Life's a little bit easier now. There's a 0, there's a 3, there's my square root of c. At which point, can't we go ahead and then begin and say, okay, we have 2/9 times 3 root 3 minus 2/9 times 0 root 0? Well, that's easy. What's 0 root 0? Yeah. Can't I reduce that to be 1 and 3? So I end up with the square root of c equaling 2 rad 3 over 3. And what do I need to do? How you guys doing? You doing it? Did you do it? 2 times 2 is 4. Root 3 times root 3 is 3. And 3 times 3 is 9. You should have ended up with 4/3. How'd we do? We do. The only difference if you use the other formula is that you would have had square root of c times b minus a times 3. This would be over here, but everything else should have been the same. And when you came down here, you would have had 3 rad c, 3 rad c, 3 rad c. You would have had to divide by 3 at the end, and you would have should have gotten the same answer. Questions? So if you were to see something on the test, if you were to see something on the test about using MVT to find C, what do you really just need to be able to do? Plug in the formula, and then after you plug into the formula, solve the integral and find the C. But where does the C need to be, just like it should be in the original MVT? The original MVT says it's in f prime of C. In this one, with the integral, where's C? Inside f. Be careful. If you don't put C inside f, you're going to mess up. All right, with that, guys, let's go grade homework and let's get stuck. Sadly, for some reason, I was trying for like 5 minutes to get my ebook to work, and the link, dead. I clicked and clicked and clicked on every link, and every link was working but the ebook. So I have my book open on the podium. I'm ready for questions once we get there. But let's go ahead and check the evens first. But after we check the evens, I'm actually going to go over the odd questions first because you guys knew what the answers were. This makes sense, right? Those are the most important questions because the evens, you haven't been able to see if you made some silly little mistake yet as far as the math, because as we can tell with these numbers, we can mess them up. Let me zoom in. Number 10, final answer should have been 19 halves, or 9.5, right? 19 halves, or 9.5. Number 50. I gave you guys lots of odds, didn't I? You're welcome. Number 50. Yeah, you're right, Patricia. That was MVT, huh? Janelle, is this why you used the second one? Is because they were using the second one usually? Yeah. They were using the second one. Okay. Well, actually, our CalcChat seemed to have done it too, so. Maybe in their mind, having the 1 over is harder than having it over here and dividing at the end. I guess that makes sense. Kind of, huh? The fraction's like delayed until later. Okay, I was just curious. That makes sense. So for them, in number 50, guys, they are doing MVT, but if you notice, they did their integral work off to the side. So their definite integral, they got to be 38/3, and then they went ahead and you could have had 1/5, or you had 5 here and you divided. You got 38/15. It's not C. It's f of c, so you have to go ahead and set square root of c equal to 38/15. So that's why I plug in as soon as possible to f. I plug in ASAP so I don't forget, because I can promise you if this is a multiple choice answer, 38/15 will be there. And that sucks because it is a big part of the problem, but is it the final answer? No, you have to go ahead and square root both sides. Sorry, square both sides. Blah, 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 blah. I apologize. Square both sides. Number 116. Did you guys end up liking the second fundamental theorem of calculus? Did you get C? Did you get it right? If you got it wrong, are you figuring out your mistake? Did you plug in your u? F of u would say e to the who squared, e to the x squared, so aka e to the x to the 4th. But you take f of u times u prime, and who's u prime? 2x. You have to plug in the u and then u prime. It was totally legal because it went from some constant up to that u. And I think those were the only evens out of that huge Mama Bahama homework that Michael was talking to me about yesterday. How'd it go? Can we start with the odds? Yeah, AJ. Why is it flipped on the inside? Was this looking at Slater or looking at CalcAB? Okay. When you were looking at the solution, your answer didn't work out, and so you went to go see how they did it? Okay. And then when you saw how they did it, something was flipped. Okay, give me an example. But A made sense. Sorry, first. Okay. Let me go ahead and just quickly do B because it's good test review anyway. So, AJ, what was your interval for number 99B?
0 to 3.
And then we're taking absolute value because we're doing speed, right? And then your function was?
5t minus 7.
And when we're dealing with absolute value, what do we have to consider? Good. So then T would have been 7/5. My question, do I need to worry about that if I'm going from 0 to 3? Yeah, totally, because isn't that like 1 2/5? It's somewhere in between. Okay, so then you split it up, okay?
Yeah.
Okay. The book may be considering the graph, whereas we said we don't care about the graph. So the book would probably go from 0 to 7/5 of your 5t minus 7 dt. And ask itself, I wonder if that's going to stay the same or flip. And it would be the exact same thing with 7/5 to 3 of 5t minus 7. Asking itself, I wonder if it's going to stay the same or if it's going to flip. How it could answer that question is it could go ahead and come to a graph and it could say, okay, what does this function look like? It's a line, right? And it's a line specifically with an intercept of -7 down here somewhere coming up. So what the book figured out is, hey, this area from 0 to 7/5 is naturally negative. I'm going to flip it. I'm going to flip it. And then it was like, oh, and this area is positive. I'm going to keep it the same. So what the book was doing is how we first did absolute value problems. But is that how you have to always do absolute value problems? No, our forever card says different. What does our forever card say? Split up the bounds and then add what? Yeah, find each area separately. And then whatever ends up happening in the math, if it's a negative, make it positive. If it's a positive, keep it the same. That makes it so we don't have to consider the graph, which the graph of a line shouldn't be hard. I mean, it's valid. But when they start throwing in like cubics or exponentials or something crazy where I might not know what the graph looks like, it's safer to have like, oh, absolute value on the outside. So if you did the absolute value on the outside, like the forever card kid, it should have worked out. It could just be like a little math mistake. And so it's not that their way was better. It was just different, and it avoided whatever mistake you might have made. Does that make sense? But yeah, your method is okay. And so what the book was doing, if it was flipping bounds or if it was putting a negative, is it was looking at the graph and saying, oh, you're opposite, you're same. It was just making that determination from the beginning instead of waiting until the end. Does that kind of make sense? What you know? Yeah, it could have been. Let me see. Yep, exact same thing. Because you would have split up at 2.5 or at 5 halves. And so what the book did on that one when it was looking at 2x minus 5 is it was like, oh, hey, it's a, there we go. So they knew that between, is it 0? Yeah, 0 and 5 halves. Between 0 and 5, because they thought about the graph. And then this one, they were like, I'm going to keep it the same, as opposed to just doing the absolute value trick. Yeah, but be careful. What I mean by it's negative, and this is where a lot of people get confused with the absolute value trick, you have to totally solve the integral. So leave these absolute values alone until the very end. What I mean by that, I'm glad you guys asked this, is you would need to do your antiderivative from 0 to 7/5, absolute value chilling on the outside. You would need to plug in your 5 times 7/5 squared. Ooh, I would reduce a 5 with that 25. Anyway, all over 2 minus 7 times 7/5. F of B minus, oh good, whew. All right, it's a little bit easier. Don't go changing, flipping any signs. Do the entire integral, including this part where you would end up with 49, there would still be a 5, 49 tenths minus 49 fifths, which would end up being negative 49 tenths. Keep the absolute value. Keep the absolute value. Don't be afraid of the subtraction. It has to happen. But at the very, very end, when you have the constant that signifies the integral, say, oh, hey, he has to flip. The same way their picture told them, oh, hey, at the very beginning, he has to flip. Does that make sense? Yeah. And then you do the same thing over here, but this guy ends up being a positive number anyway. The one mistake that kids tend to do, it's kind of like killing a puppy. They see the absolute value and they're like, no subtraction. No. You got to do what's inside first. You subtract, you add, you square, you divide, you do whatever you got to do. At the very, very end, absolute value. So then that would flip and then that would add to the other one. Yeah, good questions, guys. The absolute value, it's tricky because our brain doesn't always necessarily process right. And for some of you guys, the numbers, you might have made little mistakes and when you saw the book doing it differently, thought that your way was wrong when it wasn't. What else was going on in homework? 29. Ooh, I like it. Guys, peek at 29. Why is AJ asking about it? But why? Just be specific. Trig. Okay, so absolute value can get tricky. Are we all in agreement? What else can get tricky? Trig. Tricky trig. The bound is 0 to pi over 4? Cool. And what's inside? Oh, that's a 5. All over cosine squared? Oh, that's nice. Why is that nice? Remember our properties? So I can rewrite this to be cosine squared all over. Oh! Go team! What happens? It reduces to be 1. Hey, what's the integral of 1? 1 times the variable, whoever the variable is. If it's an x, it's an x. If it's a y, it's a y. If it's a theta, it's a theta. But I need from 0 to pi over 4. So the crazy thing is, this was actually so easy it was hard. Pi is pi over 4. Double check me. Does that look good? Cool. Sorry, I didn't write the number. That was number 29. What else do we have? Do you know? 55. What do you got, Patricia? Okay. Anything before 55? 35 and 49. I don't think we've done a forever card on b to the x backwards, right? Is that in our basic integration rules? I don't think it really shows up until next chapter. I don't mind popping around just a little bit. So let's keep popping around. We'll go to average value, then we'll come back to Patricia's question. So then, Janelle, it was number 51? 55. Guys, remember the pink ones. There are videos online that explain it, but that doesn't mean you always learn. I saw average value in the directions. Average value, there's a very specific formula that you have to plug into. 1 over b minus a. Then we have to go ahead and solve our definite integral. It could be something as easy as an addition, a subtraction, a plugging in that went wrong. However, these directions don't just ask for the average value. You guys notice that? It asks for the average value. You had to find the average value. F of b minus f of a. But in the directions, how did you guys summarize the directions? What was it actually asking you to do? Find the average value and then. Uh-oh. Did you not keep reading the directions? Maybe that's why you guys got stuck. I need to change that to thirds. That would be 48 thirds. 48 minus 16 would be 32 thirds times 4. 32 twelfths. Double check me. Average value, look good? Huh? Oh, because you can keep going. Yeah, sorry. Thanks. Now it's good? But wait. It said, find the average value and all values of x in the interval for which the function equals the average. What? Where the function equals the average value. Isn't that f of c equals? Aren't they really just being sneaky and having you do MBT? But we found who this guy is. It's 8/3, no big deal. Who's the function? 4 minus c squared. Oh, there was more to the problem than the average value. Then it said use it to figure out for what x values, and we just call them special c's, the function equals the average. And so then you would go ahead and subtract 4, which would be subtracting 12/3. Then you would divide by a negative, which would be positive 4/3. And then c would equal plus or minus square root of 4/3. 3? Does it say in the interval? That's less than, yeah, that's in between -2 and 2, so we're good. Does that make sense? Directions went further. Bummer, huh? Let's do this for sake of time. Let me see what other questions we have. I'm going to start writing them around the room because I think, at least as far as the integration, at this point you guys can help each other faster than I can help you. So, Patricia, help me out. What were the ones you were asking of in the integrals themselves? 35 and what else? Oh, I thought there was another one. Who else had an integral question? AJ? 51. Okay. So we have 35. We have 51. That's an MBT. You have another one later on, Patricia. I know that. Anything else, AJ? 75. 75, let's pause on, just because I'd rather have a picture for that one. 75, let's pause on, but I'll go ahead and write him up here just so I remember that we had him. Number 75. Patricia, what was your other one? Oh, you figured it out. Didn't you have one later on, though? I thought you had one in the hundreds. No, I'm crazy. Okay. What else do we have out there? 57? Okay. Anything else? All right, guys, for participation points, can anybody do any of the ones written on the board? First hand I see, you get your choice. Rachel, what do you want? You want 57? Take it. That'd be awesome. AJ, what do you want? Okay, 35. Do we have a 51er? Brian, take it away, bud. All right, as they come down, I'm going to go ahead and try to get a picture for number 75. Did anybody else have a question on 75? It was 10/10s. Okay, good. I was going to say, I hope we have a question on 75. Let me pause the recording because you guys don't need to hear their little whiteboard marker. Number 75, kiddos, it's not going to be on the test. It's a really good question that we'll talk about when the test is over, but we're not going to stress about it right now. So for number 75, it's totally fine with me. If you look on CalcChat, try to do what you can. But here's the dealio. What's going on with our calendar? Sorry, I forgot today was a chapter. I don't know why. The forever quiz, do we have a lot of forevers? So I was a little worried that making you guys do the forevers tomorrow was a little too much. So I'm giving you the weekend to study your forevers. Yeah, be packing up because I'm kicking you out in just a second. However, we can't just waste tomorrow. Half of tomorrow will be a work day on your test review. Look at the calendar online. Your test review is due Monday. Monday's our work day on the test review. Tuesday is the main test, which has multiple choice and 1 page of long answer. So what on earth is test part 1? It's the long answer on 4.1 A and B. Antiderivatives, which we did an integration quiz on, and motion. So tonight, what are you studying? 4.1 A and B. You're looking at examples. You can look at the review if you want. It should be the beginning of review. You can look at the practice test a little bit if you want. But tomorrow is just 4.1 A and B. Just long answer. Sound good? Antiderivatives, motion. Bye, guys. I tried to spread it out in a way that would be most helpful. Thank you, thank you. Come by if you have questions. I'll be here after school. Tell your next teacher, calculus teacher, got distracted. Yeah.
Kind of inconvenient that I mentioned it so late, but I have a driver's test now.
So you're going to miss the work days, but definitely watch the video. You're not missing any tests except for